Sathyabama Institute of Science and Technology.
Good morning. This is Abinaya from Department of Computer Science and Engineering, Sathyabama Institute of Science and Technology. So today we are going to see about what is a classical encryption technique in cryptography. So we know that if it is a cryptography, we are instead of transmitting original message, we are going to encrypt the original message and we are going to transmit. So to avoid of the hacking. So like that, we are going to see how classically they are classical encryption technique we are going to do it. These are the types of classical encryption technique. So here we are having a symmetric cipher model, another one is a substitution model, and another one is a transposition technique, rotor machine and stenography. So these are the techniques they are used in classical, how they are doing in a encryption technique. So so first of all, we need to know what are the datas we need to know now. So if it is a plain text, then it is considered as your original message. So if it is a encrypted text, so you are going to apply some encryption algorithm there. So after that, if you are getting any detail, then that is considered as your ciphertext. So if you are doing an encryption, if you are going to add some inbuilt data, then it's going to be considered as your enciphering or a encryption model. So if it is a deciphering or decryption means if you are going to retrieve your original message, then it's going to be considered as your decryption. So cryptography now, those who are studying about that, it's going to be considered as a cryptography. So if you don't know what is the data is there, even though if you are going to find out the data, then it's going to be considered as your crypt analysis. Both of the cryptography and crypt analysis is going to be called as a cryptology. Those who are studying cryptology, they need to know how to encrypt the data. Also, they need to know how to decrypt the data from the original message. So that is a cryptography. So this is the two types of classical encryption technique we are having. So one is a symmetric and another one is a conventional encryption model. It is also called as. So for example, if it is a plain text, we can able to convert it into a cipher text. So here using some encryption algorithm, you are going to convert a plain text into a cipher text. So like that, if you want to retrieve your original data, then we need to do your decryption technique. So that's what it is given as plain text, that is the original data, ciphertext, that is a coded data. So once you applied encryption technique, then it is represented as your ciphertext. So that's what here it is given. So in the ciphertext cipher model, so here also we need to know, so what is a plain text, so what is the encryption algorithm you are going to use, so what is the secret key for you are going to apply for that to do a encryption. So after applying encryption and the key, then it's going to be considered as your ciphertext. So if you want to retrieve your original data, then it is going to be considered as your decryption message. So this is an example for that how it is working. So here you can able to see this is your plain text. So you are going to apply some encryption algorithm along with the secret key. So after that only it will convert it into a decryption model, that is a decryption data. So again if you want to retrieve your original data, again you need to apply the key and you need to apply some algorithm, then only it is going to be converted into your original data. Then only you can able to retrieve your original data in your receiver side. So this is the ciphertext. So here Y represent your decrypted data, E represent your encryption model. So here you are going to encrypted your original data along with your key. So that's what X represented your plain text, K represented your key, then E represented your encryption. So likewise in the receiver side, if you want to retrieve your original data, then you need to give, you are going to retrieve your original data. So that's what it is represented as a X is equal to, I am going to do a decryption. So that's what it is represented as a D. Here how we are going to decrypt? So using your key as well as your encryptor, that is your encrypted data. So what about your then encryption? So that is the output by Y and key. So you are going to do the decryption. After that you will retrieve your original data in the receiver side. So in the classical encryption technique, we are having a two types. One is a substitution and another one is your transposition. So substitution now, instead of your original data, you are going to substitute some other letter. So that is your substitution. So if it is a transposition now, so whatever the data you are having, just you are going to rearrange the data and you are going to create your ciphertext, that is your decrypted data. So substitution now, so instead of your original data, you are going to substitute any other different data. So if it is a transposition now, just you are going to rearrange the data whatever you are having, so you are going to convert that into a decryption data. So that's what here we are having a two types. So in the classical substitution model, First type, we are having a Caesar cipher model. So Caesar cipher na, just you are going to add a key, that is a, if you are having a p na, so what is the number for the p we need to represent? Plus 3. So you are going to add a key as a plus 3. After that you are going to convert it into a decrypted data. So if it is a mono or alphabetic na, we know that if it is a mono na, we can able to replace only one letter instead of another. So instead of a, b, instead of b, c, like that I can able to replace only one letter instead of that. So based on that, here we are going to do a encryption. So the next one is a play cipher. So play cipher na, here we are having some columns. So based on that we are going to do a encryption. So after that, if it is a hill cipher, we are having some formula for that kp modulus of whatever the value we are having, that based on that we are doing to. So if it is a polyalphabetic, so we know that poly means it is a one to many. So I can represent any letter. Based on that you are going to do encryption data. So next one is a one pad cipher. So here you are going to do some mathematical formula. You are going to apply some mathematical addition, whatever the data you are getting for your plain text and the key. So after that you will receive your data. So like that we are going to see in explain. The first one is a Caesar cipher. So Caesar cipher now. So here you know that if it is a substitution, you are going to substitute instead of your original data, you are going to substitute another data. So what is a Caesar cipher means? So here the key going to be represented as a 3. So what is your plain text number? So you know that A going to be A to Z, we are having our 26 letters. So A for 0, B 1, C 2. So like that we are going to have a numerical number. So whatever the plain text we are having plus 3, so you are going to do a encryption. For example, here we are having a plain text as a H. So for H we are having a number as 7. So Caesar cipher na, plain text plus 3, that is a key. Key is equal to 3. So 7 plus 3, 10. So instead of H I am going to replace K. So like that E. So what is the E number here? 4. So 4 plus 3, 7. So in the 7th we are having a H. So that's what instead of E we are representing H. So that is a Caesar cipher, plain text plus key. So always the key value here we are going to take as a 3. So that's what here we are having a plain text as a cipher. So A na 0. So 0 plus 3, 3. In third we are having a D. So instead of A we are going to replace D. So this is the way you are going to create your encrypted data using your plain text. So that is a cipher text. So here we are having C is equal to E, encryption, key comma P. So key represent your key, P represent your plain text. So plain text plus K. So for example, if your plain text in the letter 3, 3 plus 3, 6. So sixth number la, what letter we are having, you are going to replace instead of your original data. Next modulus of 26. So like it way, so if you want to decrypt the data, so if it is a decryption na, you are going to retrieve your original data. So addition na, we know that is the opposite of addition, you need to do the subtraction. So likewise here whatever the cipher text we are having, for example 6 you are getting na, 6 minus 3, so 3 modulus of 6. So in the third letter, numerical third, whatever the letter you are going to have, so just you are going to replace and you are going to retrieve your original data. So this is a cipher text. So in this also we are having additive cipher. So additive now, so based on the name here we note that, so A represent, additive represent the addition. So here you are going to plain text plus key modulus of 26. So again in the decryption model also here we are going to do, instead of addition we need to do a subtraction. Why? Because then only we can able to retrieve your original data. So in encryption we are going to do a addition, in the decryption we are going to do the subtraction. So if it is a Caesar cipher, I can have a key only 3. But here we can use any key. In additive cipher, here we can represent key as any number based on our wish. So but the same key we need to use in a decryption, then only we can retrieve your original data. So here is the example. So hello is your plain text. So here I am going to fix the key value as 15. So 7 plus 15 you will get a 22. So in the 22 we are having a letter as your W. So instead of H here you will receive a W, that is your decrypted data. So in additive cipher, Caesar cipher, so here also we are going to do a plain text plus key, but key value here we can represent by your own. So that is a additive cipher. The next, this is a decryption. So decryption na, again here we are need to do a subtraction, because encryption we are doing addition. So the opposite of addition is a subtraction. So here in the decryption we need to do the subtraction and we will retrieve the data. So in this next one, here we are having a multiplicative also we are having. So here if in encryption side you are doing a multiplication, that is your plain text into key. What about the key? Modulus of 26. Again decryption we need to do a p into k inverse of modulus of 26. Then only you can able to retrieve your original data. So this is an example for that. So here we are having a h represents 0, 7. So here also I am going to take a key value as 7. So 7 into 7, 49, 7 7 is 49, modulus of 26. So whenever you will have more than 26, because here we are having only 26 letters only we are having. So whenever you are getting the output that is greater than 26, again we need to take the modulus. So we know if it is a modulus now, we need to take the remainder value for that. So 26 you will get, so 49, so 49 modulus of 26. So after that if it is a modulus now, we need to have a remainder is going to be as a 23. So in the number 23 we are having a x. So instead of h I am going to replace the x value. So like that you need to do the multiplication. So in the decryption again I need to do the inverse of k inverse of your plain text modulus of 26, then only you can able to retrieve your original data. So this is another model. So affine cipher, so till now we saw only we are using only one key, plain text plus key, plain text subtraction of key. Here we are going to use a two different key. Why? Because here we are securing more secured the data. So plain text into key plus k1 modulus of 26. So like that, so if it is a multiplication, you know we need to do a inverse for that. So in the encryption die I am going to use addition. So in the receiver side I need to do a subtraction. So that is a model for decryption and the encryption. You need to retrieve the original data. So here this is an example. So here also I am taking a hello. So here I am going to use, here we are having a two different keys. So that's what we are using a 7 and 2. So 7 is for multiplication, after that plus 2. So first 7 7s are 49, 49 plus 2, 51. So if I am going to take a modulus of 26, then the remaining going to be as a 25. In the 25th we are having a z. So instead of h I am going to have a z as your value. So this is like this, you need to do a encryption. So like that in the decryption also you need to do the reverse, for that is a inverse and the subtraction. So till now we saw the Caesar cipher. Caesar cipher na just along with your plain text you are going to add some key value. If it is a Caesar cipher plus 3, or if it is a affine model you can have any key and you can do a encryption. So like that you can able to do the process encryption. So if you want to do a original data, if you want to retrieve your original data, you need to do a decryption. So that's it. So next one, mono-alphabetic. So from the name itself, here we need to come that instead of only one letter, we can able to replace only one. Instead of A, B. Instead of B, D. So I can't able to replace two different values. So for example, so you can take any value. So here I am taking instead of A, M. So you can also take A, or instead of A, B also we can take it. But only one letter only we need to replace it. So for example, this is your plain text, hello, how are you? So instead of H here I am replacing A. So A. So instead of E I am replacing C. So C. So like that you can do a encryption. So likewise here again what we need to do, we need to send the tabular column to our receiver, then only he can able to retrieve the original data. So that is a mono-alphabetic cipher. So next one is a play first cipher. So mono-alphabetic na just replacing. Here in play first cipher we are going to take a 5 cross 5 matrix. So here you need to generate some keyword. Okay. So for example here I am having a monarchy as a keyword. So MONARCHY. So it going to have only 8 different letters. So but I need to fill the different columns, okay, wherever it is empty. So here how you are going to fill the column now? First I need to check from A to Z whether A is already there in the keyboard. Yes. So I don't want to write the A. Again I need to check B, whether the B is in the keyword. No. So I am writing B here. Next I need to check whether C is already in the keyword. Yes, C is there. So I don't want to write a C again. Again I need to check the next letter D, whether the D is found in the keyboard. No. So I am writing D here. We know that in alphabets we are having a 26 letter. So that's what here in the same box we are replacing I and J. Okay. So here if it is a plain cipher now, we need to generate the key. So once you generated the keyword, whatever you needed, first you need to fill it in the from left to right or top to bottom as your wish. So here I am having from left to right. So after that the remaining boxes I need to fill it. So how we can able to fill it now? So first we need to check whether the letter already is there or not. If already is there, we need to leave. If it is not there, again I need to write it in the box. So this is the way you need to create your data. So next one is a Hill cipher. So Hill cipher now, so I already told. So here we are going to take a KP modulus of 26. So everything we are taking only the modulus of 26. Why? Because here we are having only 26 letters. So that's what we are representing as a 26. K represent the key, P represent your plain text whatever we are having. So C, that is a cipher text only we are going to create it. That is a encryption. Encryption na cipher text. So is equal to K P modulus of 26. So this is a matrix multiplication. So we know that K11 into P1, P2, P3. So like that we need to perform all the operation. So after that you need to take a modulus for each and every value, whatever you are receiving the value. So we need to take a modulus of 26 based on your answer. So here we can have a data. So here this is a key 17, this is a key. So we are having the next plain text is a 15024. So P represent the number as a 15, A represent because the first 3 letter is a P. So we are having a P. So A represent the 0, Y represent the 24. So this is a number we are having modulus of 26. So we need to do a matrix for multiplication so here. So after that we are receiving the answer as a 375, 819, 486. So we need to take a modulus of a 26. We know that what is a modulus means? We need to take a remainder value. So the remainder value we are receiving as a 11, 13 and 18. So now what we need to do? So in the 11th number, what is the letter we are having? In 13th number, what is the letter we are having? So like that we need to replace. So instead of P, so the replaced letter, that is a cipher text is LNS. So like this in the Hill cipher we need to do KP modulus of 26. So that's what instead of P we are having LNS. So if you are doing for your also, so your na, so what we need to check what is the number for that. Again using the same key, the number for all the your. So after that modulus of 26, you need to do the matrix multiplication. So after that you need to take a modulus of 26 along with your answer. After that you will receive the number. So based on the number you need to identify what letter they are doing. So like that we need to do it. So if it is represented in a decryption, again we need to do a decryption of K comma P. So we know that if it is a multiplication we need to do the inverse of that KP and we will receive your plain text, that is your original data. So next one is a polyalphabetic cipher. So from the name itself it is coming that poly means it is a one to many. So if it is a mono-alphabetic now only 1 to 1. If it is a polyalphabetic I am going to replace instead of 1 to many letter. So here this is an example, the boy has the bag. So this is your plain text. The key I am going to have as a VIG, VIG, VIG. For all the letter whatever we are having, I am going to use a 3 different key for the same whatever you are having a plain text VIG, VIG. So now we see how we going to do encryption. So this is the tabular column. Okay. So plain text la first example, if I am having a T. So T is your plain text. I am going to have a I as your, here we are having a V. So V is your key. Then T, V ko whatever the data we are having, just you are going to replace it. So for like that here we are having. So instead of based on the tabular column, so plain text key we are using the data and you are replacing. So that is your polyalphabetic cipher. Using your tabular column you are finding a plain text key and matching the value and you are going to pick whatever the alphabetic is there and you are going to put, just you are going to replace instead of your plain text data. Next one is a one-time tab pad. So here one-time pad also, here it is also having a same data. So for example, so here this is your plain text come today. Okay, so but here I am having a key instead of C I am going to replace N. So instead of O, C, like that I am going to replace. So after that what we need to do now, just we are not replacing the alphabet. We are going to take the number, that is a for each and every alphabetic whatever the number we fixed we need to take. So for plain text ko we need to collect the number. For key ko we need to collect the number. After that we need to perform an addition. So here C ko you know 2 because A is started from 0, 0, 1, 2. So A, B, C. So here we are having a 2. So like that N we are having a 13. So after that we are need to perform a addition. So 13 plus 2, 15. 14 plus 2, 16. So like that now we are receiving some number. So next what we need to do, so in that number, in the number position, what letter we are having. So in the 15th number, what letter we are having? P. So in the 16th number, what letter we are having? Q. So like that we need to find out and we need to make a ciphertext, that is your encrypted data, we need to find it out. So that is a one time pad. So till now we are substituting an alphabet alone, but in one time pad we need to take a number for a particular alphabet for your plain text as well as your cipher text. We need to take a number and we need to perform addition. So based on the answer, we need to take what alphabet is replacing there. So like that we need to perform a one time pad. So next, so till now we saw only the substitution technique. So we know substitution, just instead of one data we are substituting some other data, maybe based on your addition or subtraction or multiplication or using some mono-alphabetic like that. Okay. So now we are going to see the next topic, that is our transposition technique. So if it is a transposition, whatever the plain text you are having, just I am going to rearranging the data. That is your transposition model. So here this is your plain text, meet me after the party. So this is your plain text. So how we are going to replace? Here I am having a depth 2 na. So like this. So you are having a two different rows. So meet. So here you can able to see. So depth is 2. So M-E-E-T, meet. Next M-E. So A-F-T-E-R. So like that you need to write it in a zigzag way. Okay. So here if depth is 2, so I am writing as a meet me after the party. So this is the data. So once you are completed, then how we are going to write it in the ciphertext now? First you need to write the first row. So M-E-M-A-T-R. So M-E-M-A-T-R-H-S. Once you have completed this line, so after that you are coming to the second line. After that you need to create your ciphertext. So in transposition technique, just whatever the plain text you are having, based on that we are going to replacing the data. So just you are going to rearranging the data. So here I am given a depth is 2. So that's why meet me after the party. So depth is 2. So we are having it in a zigzag way. So once you have completed the writing work, then you need to create your ciphertext. First you need to write the line, first line, whatever the letters you are having. Next we need to come into the second line, then we need to write whatever the letters we are having. So that's what M-E-M-A-T. So M-E-M-A-T-R-H-S-A-T. So second line we are having a E. So E-T-E-F-E-T. So like that it is going on. So we'll see the next model. So this is also another model. So first here we are having a number. I am going to represent the key going to be as a, you can give any number 5, 6, but it should be in order, then only it is easy for you to take it the data. So 5, 6, 4, 1, 3, 2. So this is my number, that is my key. The input, that a plain text is the book is suitable for self-study. So you need to fill it from the T-H-E-B-O-O-K, book is suitable for self-study. So you need to write it. So next, how we are going to convert it into a ciphertext? First we need to take, so what is the number here? It is a lesser number, that is a 1. So in the 1, whatever the letter, in the one line, whatever the letters we are having. So B-S-L-E-D. So B-S-L-E-D. So in the next, what is the next number we are having? 2. So 2 la whatever the letter we are having, O-I-F-F. So O-I-F-F. So like that. 3 la whatever the letters we are having, O-U-E-L-Y. So O-E-L-Y. So like that you need to create your ciphertext. So this is also the another model. So here we are going to use some number. So it whatever the number you are writing, you can able to write it. So but once you are picking the letters, whatever we are having, so first we need to take the less number. So like that we need to go it in a ascending order wise. You can able to create your ciphertext. So the plain text, the book is suitable for self-study. For that plain text, the ciphertext created is B-S-L-E-D, O-I-I-F, so on. So this is also called as a rail-fills technique. So here also Niche Academy is the best. So depth is 2. So N-E-S-O-A-K-A-D. So Niche Academy. So like that we are writing in the zigzag way. So in the first line, whatever the letters we are having, N-S-A-A. So N-S-A-A like that. So after that in the second line we are having E-O-C. So like that we are finding the data. So this is another model. If the depth is 3, so T-H-A-N-N-K. Thank you very much. So you need to write in the depth 3 in a zigzag way. So once you written, so you need to take in the first line whatever the letters we are having, TKVM. So TKVM. In the second line, what the letter we are having, HNYUEY. So like that you need to write the data. So next one is also the transposition. So same key whatever we are using we are having. So next one is a row column transposition. So this is also another example for you. So here the plain text kill coronavirus at 12 am tomorrow. The number key I am going to use a 4312567. So first you need to fill all the data. So after that you need to have a data for that. So first one whatever we are having TOOT. So TOOTR. In the second number we are having AISWU, say ASW. So like that you are creating your cipher text. So the next model is a stenography. So stenography na, so for example we know right we are having a hidden ink and all right. So like that we are going to have hide your original data. So this is an example. So this is your original data. Simply encrypt correct reading exactly twice. So instead of sending the plain text, here I am going to take only the first letter for each and every word and I am going to send. So that is your stenography model. So hiding, you are going to do some hiding the data. So we know, so what are the types of stenography now? So we are having a character making. So character making now, this is the, instead of the whole sentence, I am going to transmit only one word, that is your secret. Also we are having an invisible link also there, pin punches. So pin punches, so whatever the data we needed, just I'm going to punch it. So next one is a typewriter color ribbon. So like that you can able to transmit a data that in the encryption format using your stenography. So last type is your rotor machine. So rotor machine, so till now what we done, we only do a mathematical calculation, we only do the substitution model, everything. But here if it is a rotor machine, so if I'm going to give input as a A na, so it will rotate and it will generate your data, whatever the machines we are enabled for that. For instead of that we are fixing a 3 rotor machines, instead of A it going to have a, instead of that it going to have whatever the 24th letter we are having, it going to display. So instead of B, it going to replace some other data. So it will do automatically and it will do a encryption and it will find out the data. So this is the rotor machine. So till now we only do all the process, but in rotor machine it will do the process by your own and it will do the data. So that's for encryption and decryption technique. Thank you.